Hello boys and girls, this is the Unit 1 assessment review on square roots and cube roots. Number one says list the first 15 perfect squares, which are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, that is a 4, 169, 196, and finally 225. And you might say, how can you memorize those perfect squares in order like that? Well, actually I didn't. I was counting to myself. I was going 1 squared, 2 squared, 3 squared, and I kept going all the way up to 15 squared, which is 225. Okay, so hopefully, yeah, and it's really, to tell you the truth, I almost do have them all memorized, but every now and then I kind of lose count and I just have to ask where I'm at. But it's not that difficult. You need to have your square roots memorized up to 15. Okay, numbers 2, 3, and 4, it says identify the 2 square roots of each number. Okay, well the square root of 64. Hey, look up here. The square root of 64, it's up here, and that was 8. I know that 8 times 8 is 64, but negative 8 times negative 8 is also 64. That's what I was looking for. Some people didn't understand, and they just put 8 times 8, and they thought, okay, those are the... No, I wanted the 2 square roots. 8 is a square root of 64, and negative 8 is also a square root of 64. Because when you square either one of them, you get 64. And you drop the radical. Some of you are in the bad habit of writing the radical down with the answer. And you wrote the square root of 64 is the square root of 8. That doesn't make any sense. Okay? The square root of 64 is 8 or negative 8. The square root of 121 is 11 or negative 11. And the square root of 81 would be 9 or negative 9. Next, 5 and 6, it says identify the cube root of each number. Okay, so we have the cube root of 27. It's simply asking what times itself, identical factors would give us 27. And the answer is 3 times 3 times 3. So the answer is just 3. But I'm showing you the work down here. That 3 times 3 is 9, and 9 times 3 is 27. So the answer is just 3. The the cube root of 125 is asking the same question. What times some number, and that same number 3 times, would be 125, and that would be 5 times 5 times 5. So the answer is just 5, just 5. But once again, I'm just showing you the work. 5 times 5 is 25, and 5 quarters is $1.25. So our answer is 5. Next, numbers 7 through 10 says simplify each expression. So let's take a look at our first expression. You would read this, the square root of 49 plus the square root of 196. Now we have 3 operations altogether. I have 2 square roots, which are just negative exponents, and I also have addition here. Now, as always, follow the order of operations, and the order of operations will lead you to the correct answer if you calculate correctly. Okay, and let me make this very clear. Order of operations is never an option. You must always follow it. When you choose not to follow order of operations, it's going to lead you to the wrong answer. Okay, so we know we have to do our radicals first, which are really just negative exponents. And which radical do you do first? Well, I do this radical first, whichever radical comes first. So I read left to right, and I have the square root of 49 is 7. Okay, and then the square root of 196 is 14. And then I do my addition operation next. Okay, my last operation, 7 plus 14 is 21. Okay, you bring down all of your information step by step until you have the last operation. Okay, let's take a look at number 8. Number 8, you'd read this, the square root of the difference between 375 minus the square root of 9. Okay, now we have two radicals, and two subtraction signs. Okay, and normally, okay, we would do the radicals first. In fact, we do the radical first. Okay, and we do this radical right here in it. But inside of this radical, there is an operation embedded. Okay, find the square root of the sum. Find the square root of the difference between 375. You have to find the difference of 375 first, then find the square root of that. So we have to do that first. And 300 minus 75 is 225. Now the radical is still there. We didn't get rid of it. We just did the operation inside the radical. So we bring the radical down. We didn't perform the radical yet. We didn't do the square root operation. And we bring down the rest. Okay. Now the square root of 225 is 15. The radical is gone. And then we can do this square root over here. The square root of 9 is 3. Okay. So we bring down all of our information, including the subtraction sign, and the only thing we have left is one operation, 15 minus 3, which is 12. Boys and girls, we have two more expressions to simplify. Number 9 says, what is the, you'd read this, what is the cube root of 8 plus the square root of 4? Okay, we have to do our radicals first. Okay, and we just read left to right. Our first radical is, what is the cube root of 8? And that is 2. Okay, we bring it down. Okay, we're performing, see this radical, the cube root, that is an operation. We have to perform that operation. Once you perform the operation, we get rid of the operation sign. Okay, the cube root of 8 is 2, because 2 times 2 times 2 is 8. And then I bring down my addition sign. And then I can do my next radical, the square root of 4, okay, which is 2. Okay, the square root of 4. 2 times 2 is 4. And then my last operation, finally I do my addition. 2 plus 2 is 4, and I'm done. That is my answer. Let's look at number 10. Now number 10 is the square root of 16 minus the square root of 169. Okay, now I saw some people, now you're going to get a negative answer here if you figure out this. The square root of 16 will be 4. I have to do that radical first. I bring down my subtraction sign. And the square root of 169 is 13, because 13 times 13 will give me 169. I perform my operations. The operation signs are gone. The only operation I have left is the subtraction. And 4 minus 13 is going to give me a negative 9. A negative 9. Okay, now numbers 11 through 14, it says each square root is between two consecutive integers. Name the integers and approximate the square root to the nearest hundredth. So we want to find the square root of 17 to the closest 100th. Well, when I take a look at 17, I know 17 is not a perfect square. Okay, but I know that the square root of 17 comes somewhere between the square root of 16 and the square root of the perfect square, 25. Okay, and I know the square root of 16 is 4, and the square root of 25 is 5. So 17 is somewhere in between these two. It must be greater than 4, but it has to be less than 5. And I can tell that 17 is closer to 16, so my answer is going to be closer to 4, because the square root of 17 is closer to the square root of 16 than it is 25. Okay, 17 is closer to 16, so it's going to be closer to 4. If I was going to approximate to the closest whole, I could stop right there. But it asked me to go to the nearest hundredth. So this is the next step that I need to take. Okay, I need to find it to the nearest hundredth. So what I do is I take the difference between my first two square roots, which would be 17 minus 16, and that's going to be my numerator. And then I take the difference between my next two square roots, which would be 25 and 17. And when I subtract, I'm going to get 1/8. Technically, my answer is 4 1/8. But it asks me to go to the nearest hundredth, so I'm going to have to change my fraction here, convert it to a decimal. So I simply take 1 and divide it by 8. 8 will not go into 1, but it will go into 10. So I'm going to treat the 1 like a 10. 8 goes into 10 one time, and then I subtract. 1 times 8 is 8. I take 8 away from 10, I get 2. I bring another 0 down, and now I have 20. 8 goes into 20 2 times, and I can stop right there. I can stop right there because now I have 12 hundredths. And what I do with this 12 hundredths, I add it to my 4. So I can have a closer. I know. Remember, we said that we know that the square root of 17 is somewhere between 4 and 5. Okay, it's got to be greater than 4 and less than 5. So I add my 12 hundredths on, and my final answer is 4 and 12 hundredths. Okay, that's a pretty close approximation. Now for number 12, we have to find the square root of 115. 115 is not a perfect square, but it will lie somewhere between the square root of 100 and the square root of 121. And I know that the square root of 100 is 10 and the square root of 121 is 11. And this time, okay, it's between greater than 10 and less than 11, but this time the square root of 115 is closer to my larger number. When it's closer to the larger number, okay, remember we got to keep it inside of 10 and 11. It's got to be less than 11 and greater than 10. Whatever hundredth we get, we can't add it. This time we're going to have to subtract it. And there's also something else funky that's going to happen here. Okay, if we were going to just round it to the nearest whole, we'd say it's 11, but we need to go to our nearest hundredth. So once again, I take the difference between my two square roots, 115 minus 100, over the difference between my next two square roots, which would be 121 and 115. And when I subtract, I'm going to get 15 over 6. Now, I have an improper fraction. Okay, right away that should be kind of alarming you, saying, well, if I have an improper fraction, that's going to give me a mixed number, and when I go to add or subtract, it's going to throw this off. Okay, so anytime you have an improper fraction, which you always have an improper fraction when you're closer to the higher number, what you need to do is you need to flip our fraction and change it to its reciprocal. Okay, and you take 6, and so you take 15 sixths and change it to 6 fifteenths. And now I can divide. So I'm going to take 6 and divide it by 15, because every fraction is really a division problem. 6 fifteenths, what does that mean? It means 6 divided by 15, and that's exactly what I'm going to do. And 15 will go into 60 exactly 4 times. And I can stop right there. You might say, well, I'm supposed to go to the hundredth. Well, just add a 0 there. It's 40 hundredths. Now, what do I do with this 40 hundredths? Once again, if I add it on to the 11, it's going to take me outside of this range. Okay, I already know that 11 would be too high, so it's got to be less than 11 but greater than 10. So instead of adding, I'm going to subtract. So I take 11 and I subtract my hundredths from it, 40 hundredths, and that's going to leave me with 10 and 60 hundredths, and that's my answer. That's my approximation. The square root of 115 is 10 and 60 hundredths. I've got 2 more approximations to do. I have to find the square root of 88, and I know the square root of 88 is going to be somewhere between the square root of 81 and the square root of 100, which is somewhere between 9 and 10. So the square root of 88 is somewhere between these two numbers. It's greater than 9 but less than 10. And it is going to be closer. 88 is closer to 81, so it's going to be closer to 9. It's going to be on the low side. And once again, okay, I need to go beyond just finding it to the nearest whole number. I'm going to find it to the closest hundredth. And how do I do that? I take the difference of my first two square roots, 88 and 81, and that's going to be my numerator. And I find the difference of my second two square roots, which is 100 minus 88. And that's going to give me 88 minus 81 will give me 7. And 100 minus 88 will give me 12. So there, technically my answer is 9 7/12, but I need to change it to hundredths. So I take this fraction and I convert it to a decimal. I take 7, okay, because 7/12 means 7 divided by 12. Think of this fraction bar, it's really a division sign. 7 divided by 12. A fraction is just an incomplete division problem. Okay, 12 will not go into 7, but it will go into 70, and it's going to go into 70 approximately 5 times. I know that 5 times 12 is 60. I subtract, I get 10. I bring another 0 down, and 12 will go into 100 about 8 times. Okay, that's going to be, I think, 96. I can stop right there. I don't really need to go any further because I have 58 hundredths. And what do I do to the 58 hundredths? I add my 9 to it because I know it's 9, but it's greater than 9. The square root of 88 is 9 plus 58 hundredths, which is 9 and 58 hundredths. There we have it. Okay, now let's find the estimation. Let's estimate the square root of the negative of the square root of 130. Now don't let this negative throw you off, okay? You're still just working with the square root of 130, but whatever your answer is, you have to change it to a negative. That's all. That's all. The negative is on the outside of the radical, not on the inside. If it was on the inside, that creates a different complexity, which we're not going to deal with now. So the square root of 130 has to be between the square root of 121 and the square root of 144. I know the square root of 121 is 11. The square root of 144 is 12. So the square root of 130 is somewhere in the middle. And it's going to be closer to 11, the lower whole number, than 12. Because 130 is only 9 away from 121, but it's 14 away from 144. So again, we're not estimating to the closest whole, we're estimating to the closest hundredth. So we take 130, subtract 121. After you do this a couple times, it looks pretty cumbersome at first and very confusing, but after you do it a couple times, you got to practice it. It becomes second nature. And then our denominator we get from taking the difference between these two numbers. So I take 144 and I subtract 130, and I end up getting 9 over 14. And the answer really is 11 and 9/14, but we need to change this to a decimal because we want the hundredths. So I take 9 and divide it by 14. 14 will not go into 9, but it goes into 90. 6 times. 6 times 4 is 24. Carry the 2. 6 times 1 is 6 plus 2 is 8. I subtract. I get 6. I bring another 0 down. 14 goes into 60 approximately 4 times, and I can stop there. I have 64 hundredths. What do I do with that 64 hundredths? I add 11 to it. So my answer is 11 and 64 hundredths. Okay, once again, I know the square root of 130 is somewhere between 11 and 12. It's greater than 11, but less than 12. I found my hundredths by dividing the difference between my first two square roots and the difference of my second two square roots. I got 64 hundredths. But once again, don't forget about this. Don't forget about the negative sign here. So the answer actually is a negative 11 and 64 hundredths. Finally, our last two problems. Number 17. Mario is designing a video game and has to build the board so that no square in the game is more than 24 inches square. Okay, so all the squares can be 25-inch square or less. Okay, what is the longest side length of any square? Well, okay, well if the largest square can only be 25 inches square. Okay, then what are the longest side? What's the longest side of this largest square? Well, okay, guys, we know it's got to be a 5 by 5 because 5 times 5 will give me 25. So the answer is 5 inches. Okay, it's not that hard. Okay, that's all you had to do. Draw a picture. Okay, the largest square is 25 inches square. What could the longest possible side be? It's got all the sides have to be 5. I mean, we could have a 4 by 4 square, but that'd be 16. Okay, or 3 by 3 or 2 by 2. But those are all small. It says what is the longest? And if we try 6, a 6 by 6 would be 36. That'd be too big. Okay, I talked long enough on that extremely easy problem. Okay, number 18. Max knows everything there is, bad English, there is to know about baseball, such as the dimensions of each square base. If he tells you each base, except for home plate, of course, which is 5-sided, it's a pentagon, is 225 inches square, what is the length of each base? Well, it says that each base is what? 225 square inches. So, and it's square. So it's 225 inches square. That's the size of each base. Okay, that's the area. What is the length? Well, we know all these lengths are going to be the same since it's a square. Each side is the same. Okay, and what times? We know that we get area by taking length times width, and length and width are both the same thing, so area is equal to any side times side or side square. What is the square root of the area? That's going to give us the side, and the square root of 225, or what times what will give us 225, is 15. Okay, so the answer is 15 inches, and we are done.